Hi everyone, my name is Ani.
And I'm Christina, and we are going to be reviewing a problem from chapter 13. This is number 10, and this was done by request by a couple of students. So first we're just going to start by reading the problem and highlighting some key factors that we should be paying attention to. So an 8-kilogram infant requires a continuous infusion of a drug to run at 1 milliliter per hour to deliver 4 micrograms of a drug per kilogram per minute. Calculate the milligrams of the drug that must be added to a 1,000 milliliter IV infusion. Now, one thing that I'm going to highlight in green is the milligrams here, and that's going to indicate what our final problem unit should be. So what we're searching for is milligrams. And a good way to start setting up this problem, and what I always like to do, is just to write down all of the important values that were given. So we have an 8-kilogram infant, and it's going to be running at 1 milliliter per hour. And then it's going to be delivering also 4 micrograms of drug per kilogram per minute. And I write it that way, but you can also write it like this, however you feel comfortable. And then the other value that we need to look for is that we are adding whatever solution we find to a 1,000 milliliter solution to make the total solution. So I'm also going to write the number 1,000 as well. And our final value that we're looking for is milligrams. So what we can do here is choose any of these initial values that we have here to try to convert it to the milligrams. And you would be using that by using dimensional analysis to be able to cancel out the units to get the final unit of milligrams. And what we always recommend is to start with any value like this, where it's multiple units, or you can even start with milliliters as well, or the 8 kilograms. We choose to use this one right here because this value right here, the microgram, is in the same format of the milligrams, which is what our final value is. It's just another size of the milligrams. So we're going to convert it to that in the end. So what we're going to start with is 4 micrograms over kilograms per minute. And what we can do first is either focus on converting the minutes to, let's say, hours, which is another version of our problem here. It's in the continuous rate of 1 milliliter per hour, or we can focus on the kilograms, is what we have here, the infant size. So what we can start with is the kilograms, and what we're going to do is just multiply it by 8 kilograms, which is the weight of the child. And once we do that, we are going to basically cancel out the kilogram value here. And since 8 doesn't have a denominator, we're just going to keep it in this problem set looking like that, and we're going to move forward. And let me rewrite those for you. And then after we've finished with the kilograms, we're going to choose another value that we can try to convert to, and I'm going to focus on the minutes now. So what we have here is another conversion factor that states that we have an infusion rate of 1 milliliter per hour. So what we need to do is convert this minute to hour so that we can cancel out the infusion rate as well. So what I'm going to do here is I'm going to say there's 60 minutes in 1 hour, and that will then cancel out our minutes. And then I'm going to multiply by our infusion rate, which is 1 hour per 1 milliliter. And those get canceled out as well. So essentially right now, what we are left with is the 4 micrograms per milliliter. And we're going to continue to move forward from there. Now, what we can do to cancel out the milliliter is to multiply by our total solution right here, which is what we're given here, the 1,000 milliliters. So what I'm going to do is multiply by 1,000 milliliters, and that will then cancel out the milliliter right here. So essentially what we did is we canceled the kilograms, we canceled the minutes, and we canceled the milliliters as well. And what we're going to be left with is micrograms. But the issue is that our problem is not asking for micrograms, it's asking for milligrams. So what we have to do now is convert the micrograms to milligrams. And what we can do is then add another set to multiply, and in each milligram there are 1,000 micrograms. CG, sorry about that. And then in the end, we're going to be able to cancel out the micrograms and be left with milligrams with our final value of 1920 milligrams. Now with this step right here of the milligram to microgram, what you can also do is convert microgram to grams and then convert grams to milligrams if you feel more comfortable doing it in a more stepwise process, but you can always use it like this. It just depends on how comfortable you feel in the conversion process from micro to gram and then back to milli or anything else that's available as well. So this is how you calculate this problem overall. Again, you don't have to originally start with this 4 microgram per kilogram per minute. We just started with that because we're a little bit more comfortable starting with a unit that we know is going to be in our final value. You can always start with the kilogram here, the 1,000 milliliters, or even your infusion rate, and you will still end up getting the same answer. So if you have any other questions, you can always contact us and we'll go over it with you again. Thank you.